Okay, hello everyone. I think this must be our first design review of 2022. We are looking at incremental language development for Wolfram language, an assortment of different questions and functions. So we talked about until.
Yep, we talked about it last time and we wanted to do a quick follow-up. I did an inventory on various other languages because we were concerned about the argument order, and the general finding was that test body was pretty consistent in most languages that weren't procedural, and there were almost no instances I found where we reversed argument order between while and until. So I think that makes a pretty strong case for having until be until test comma body if we want to have it. And then we also have Danny here as well, who wasn't in the last meeting, if we want to talk about any.
I think until prime q x plus plus seems okay. So the issue is that until that's true, do this.
Mm-hmm.
And the failing case, the last case, is what we're concerned about. Now we've got nest while, but we don't have nest until. Right, and that's the next question: is do we need nest until?
No, don't we already have a situation where we allow to go beyond by one?
I'm sorry, what do you mean?
I mean, maybe I'm misremembering, but nest while, doesn't it allow us to go beyond the while clause being true?
No, I don't think so.
No, it does. The fifth.
Maybe I'm thinking of
applies
fold
F an
while.
extra n times.
It does? Oh yeah, an extra.
Oh, that's
I'm
the
not
one.
sure. I'm not sure that lets you do the until thing though. Like I think even if the predicate becomes true in that extra n times, I'm not sure if that means it continues or if it just runs it n times and stops. Right.
Yes, but so what would nest until do? So nest while does
nest until would be basically the same as nest while, except that it would run the test. Even if the test was false at the beginning, it would still run its first iteration.
Yeah.
First iteration. Okay. Oh, I see. The while would fail otherwise. The while would fail at the beginning, and then it would be over, or will be over. Okay, so just so I understand. So until this is true, do this. As opposed to...
It's more do this until. It makes a difference.
Yes, it does. Wait a minute. Which way round is it? Until this...
Do this until. That at least is the way I've always interpreted it. What Nick showed up might conflict.
Do this until. So until prime q x plus plus is what's being said here, right? So
no, it's saying x plus plus until prime q. That's why we talked about the argument order last time.
Perhaps it would be useful to have the usage message of while. Yeah.
By the way, why are those? Sorry, the font is smaller there than the body font. Seems wrong. Okay. I mean, is there a possibility that to avoid this confusion, we could add another word? Maybe it's do until. I don't think it is quite do, but
repeat until is common.
Yeah. Repeat until is a pretty common syntax, pretty common idiom.
Sounds a bit though like, I mean, we have some repeated and stuff like that, but those are totally different.
Yes.
We don't actually use repeat. Just no, repeated and repeated no.
No, we avoided repeat because we wanted to wait for let's see.
So the idea is that the usage line of until will be identical to while, but reversing test and body in the explanation.
So let's write it. What would it say?
Be until it first gives true instead of first fails to give true, right?
No, but it's not evaluates test. Evaluates body, then I'm so confused.
Evaluates body, then test repetitively until test first gives true. Was that?
I
No,
think it's
then
exactly
test
the same
and
thing, except that it says evaluates body, then test. When while says evaluates test, then body. Otherwise, I think it's the same.
repetitively until test first gives true. Is that right?
Yes.
The fact that we've been so confused about this and we've managed to go a third of a century without until doesn't make a great argument for until.
Somebody did bring this up recently in Stack Exchange and was happy that we finally had it, albeit in the function repository.
Well, that's nice. But what do we think about this? I mean,
clearly, I've liked to have a concept like this, several times.
All right. Well, I mean, I think it's harmless to have, and it sounds like so it would be until test comma body. And so it's a little bit bizarre that you evaluate body first, even though the argument order is this.
Yeah. We could do it until body test. I guess that doesn't seem right.
We don't want to do it. We don't want to do that. We don't want to do that. We don't want to do that.
I think this is better because it refer.
All right.
It's both functions while and until are focusing on the test.
Yeah.
All right, let's implement this. Fine.
Okay.
Well, it's just a matter of promoting it, documenting.
Yeah, I understand.
Okay.
So this is a tangential point, but I noticed that we do have one undocumented system function called wait until, which seems to be buried kind of internally and only ties into the front end somehow. But I just wanted to mention it since we have various other while functions, but this would be the first until function.
Wait until. Wait a minute. Wait until.
That sounds like one of the task functions.
Yeah, it's a computation. Yeah. No, it's for parallel computation, isn't it?
I don't believe so. I didn't dig.
Sure it is.
It's something. There's some tie-in.
Looks like
some
it
options
should.
About whether wait until operates or not.
It looks very much like it's related to parallel.
Yeah, I assumed it was like parallel, wait all, wait next, etc.
Wait one.
Yeah.
Or wait first.
Well, let's ask Roman, I guess, or somebody can look at the code.
Okay. Yeah, I'll follow up on that, and if there needs to be a discussion about it, we'll bring it back another time.
Okay, let's keep going.
I find it funny that wait next refers to a first rather than being called wait first.
Actually, it looks like wait until is some sort of it's maybe some sort of front end thing. It's like it waits for some condition for up to some maximum wait time.
Oh, so it's nothing to do with this. So it's something to do with the dynamic subsystem.
Oh.
Yeah, it looks like there's some sort of internal tie-in for monitoring of some things, front end execute, wait until something returns
All
a
right.
done signal, then
So let's contact the appropriate people and find out what
Yeah.
the story is there.
Yeah.
Okay, let's keep going. Now I have a meta question. I mean, there's a ton of functions in the function repository, and we're focusing on these pretty specific ones. What is determining this?
So this set is a set we went over. I've been triaging the function repository functions into categories, and then what we're working in terms of following up on that is going to appropriate developers. So things related to associations, checking in with Constantine, things associated with visualization, talking to Brett to give them a first pass through whatever. I mean, Danny and Richard and a handful of people have been picking out potential candidates, and I've been scanning through the hundreds of ones that go through there and trying to categorize them so that we
All right.
filter
Okay. So
it
how
out
many?
before-
What is our flow rate? I mean, how many? In this. I mean, I think how many do we expect to promote this year? A few tens of functions.
Well, propose far more, but actually
Yes, I know.
promote few tens at most.
Okay, but I also think that in addition to these utility functions, there are some ones that are a bit more ambitious that we should look at. And
Oh,
a bit
we're
more-
proposing ambitious ones. You just want them put onto the ILD list, I guess.
Yeah, that's what I'm saying. Yes.
Okay.
Yes, I'm saying these are very much utility functions. And okay, let's look at some of these. I mean, what happened to the one I was bringing up before about find the position of the maximum thing in a list?
Yep. So that is the third sub item in this section here.
Oh yeah, look
of-
at that. Well, what do you know? Okay, fine.
Yes,
Okay,
these are
take
kind of related.
after. Is this useful? And is there a more general concept of see the one thing that I wonder about is part specifications. I mean, right now we have, in part specifications, what do we have? We have, an array, we have, things like the spans, and what would happen if we had the notion of a symbolic part specification? So for example, if we said something like array this, I mean, this is a little bit crazy. Let's just say, I'm just going to put this in as a crazy thing. Okay, what if we had something like that, where what that means is you're going to find the part that's two after the position. So in other words, this is equivalent to some kind of internal, you could do this in two steps, but this is a symbolic way of doing something like this.
So what would the part position X be there? Is that the notion?
It would
of-
evaluate to the position of the first X that appears in an array.
I see.
Wouldn't adding 2 to that be a completely unrelated position?
It's a different position. Yeah. I mean, this is saying if we say, okay, so let's say we did this. Let's say we had something here that was a let's say this is a very bad name, but selected part of max. And let's say that, and maybe even it had some kind of comma n here, the n of those, the first n of those. So in other
One
words,
question,
yeah.
Sorry, I mean, one question about these sort of fancy indices is how they would interact with something like data set or with query, right? Because with those, you can have spans and other indices, but you can also have arbitrary functions, and those functions get applied to the list.
Indeed, but notice that those occur inside single brackets here. In
Sure. I mean, it's not. I don't think it's really ambiguous, but I mean, 2 points. I mean, the first point is just that, I mean, if we're basically trying to emulate that behavior, but inside of part using new heads as opposed to using the existing heads, then
Maybe
that might not be.
Yeah, that might not be
Yeah.
that sensible. But so select, for example, with a criterion would be, so what we would be saying, one possibility would be something like array of select of the criterion, which would be the analog of the dataset way of doing it.
Something
Is that
important here, something important is that we should distinguish part specs and position specs. So I would be more in favor of having these inside the extract, which seems more powerful. A problem with
we have
part,
such nice syntax for part, but yes, that we have these factored, these out of product cases.
Exactly, because with an array, what does it mean the max if you are at level 3 in an array?
Okay, but so in this case, if I make this into a data set, then I can say in that data set, select prime q, can I not? Yes, so that's doing essentially symbolic part specifications.
Mhm.
And Nick on our live stream is pointing out that maybe we should invite Nick to these meetings. Oh, it's a Nick function as well. Cases for matching sub-expressions together with their positions. Oh, I see. This is slightly, oh, an example for cases with position pattern. Oh, here, what is position pattern? Wait a minute, what is position pattern? Is that another? Oh, it's a special head for matching sub-expressions together with their positions. How interesting. Oh, I see. That's an interesting construct. So that's the thing where we're saying, in addition to, I get it now, what this is. In addition to cases where we're saying, for example, cases of range of 10, comma, blank integer, we're saying that as well as make their part. It's a combination of content. This is a combination of content and part position and position. It's selecting. Go ahead.
I was going to say that we have discussed something similar for replace. The idea of replacing, taking into account simultaneously position and content. Because now,
Yes.
right now we have separate replace and replace part, but not something that looks at both simultaneously, like these would.
Right. So the question is, yeah, but by the way, do we have trees people here? Do we have trees people here?
Yep.
Yes, we do. Okay, because I have a big objection. I have a big complaint about trees. Sorry, I know this is slightly off topic, but it's not as off topic as one might think. Okay, so I'm gonna describe my objection about trees. Let me bring up something. Hold on 1 second here. Help, where is the thing I just was bringing up? Oh, here we go. Okay, so I had a big tree. Here's a big tree. Okay, so if we look at this tree, I just want to get the top 3 layers of that tree. How do I do it?
Only way I can think of currently is to enumerate every other position and delete them.
That's ridiculous. So what I want to do, I want to find out, so I did a tree extract here of tree level, and even that didn't work.
It's effectively doing tree level on the tree.
Well, I mean, so if I have my tree here,
Yeah, I think the difficulty is that you have to actually modify, like,
Which, by the way, this
is
isn't. Oh, sorry.
No, sorry. Go ahead. Go ahead.
This is an attempt to extend the language of position specs to include things like tree level, select.
I know. This is why I'm bringing it up. It's because this is a symbolic level. This is a symbolic specification. So, for example, here I think I've got my. How do I do if I say tree size, and then I say tree, for example? Yeah, okay. So that's got 1422 nodes. Okay. So now I want to extract the top of that tree. So what I say is tree extract of that tree, comma, now. What do I do to get to the top level of the tree?
All.
All? What do you mean? That will give me the whole tree.
No, do it. That gives you all of the children at level 1.
But that's all the subtrees. That's not what I want. I want the tree down to level 2.
Right. I think the problem is that if I think it's called tree delete. If for the index specifications you could use all, then it wouldn't be that hard to do because you could just say.
That's a grotesque way to do it. I mean, because we're used to an expression. Well, actually, so the question is, what's the corresponding thing for an expression? Let's say I have an expression, I say nest, of f, x, 7, and I want to get, what would it look like? I see what you're saying. What you're saying is, in an expression, if I want just the top few levels, what do I fill in for the rest? Because for a tree, I can just remove it. I can leafify at level n, right? Whereas for an expression, it's not obvious how you leafify. You see what I'm saying? And
sorry, I think the correct syntax for this would be tree delete, tree levels 3 to 6 or something like that.
Okay, so tree delete, but I don't think that's the right way to think about it. Sorry, say it again. Tree level.
I would say you enumerate the 3 levels you want.
You go 3 to infinity.
Exactly, something like that.
No, but I don't want those. I want the ones at the top. I want to keep the ones that.
Yeah.
Oh, I see. So 3. Is it in a list or is it
list 3 comma infinity
or -1? Yeah.
Yep.
It doesn't work now, but I think this would be the syntax to do that.
Mm-hmm.
Okay, but so then what you're saying is, if I look at this expression here, I could as well say delete. If I did that, see, in the case of a tree which has no further branching has a null in its tree expression. Is that a correct statement? What do we do? Or is it none? What do we do
None.
here? Okay, so let's just look at how that works. So we say tree of tree. Let's see, it's the payload. And then, so let's say that's an A. And then we say tree of none, comma B, not tree of none, comma C, correct?
B comma none.
Oh, because that means there's no subtree going beyond that.
Mm-hmm.
The payload is B, but there's no subtree going beyond it. Okay, all right, fine. So now the question is, what you're saying is, what I want to do is I want to remove, that's why you're saying tree delete removes the subtrees beyond a particular level, but that's a very weird way. You see, what I'm used to thinking about is I've got a graph. Let's say this tree was a graph. I would find the graph neighborhood of the root, and I would just go a certain distance in the graph neighborhood. By the way, Danny, I'm pretty sure maybe it's somebody else, has some weird background noise. Okay, doesn't matter. Okay, in any case, you understand what I'm saying? That if I turn this tree into a graph, then I can extract the top of it by just the graph neighborhood of the root.
Yep.
And it's very weird having to think about tree deletion of all the levels to be able to get that. I think I want a tree top of some kind, or a tree. What should it be? I mean, it's because the only place where that makes sense is at the top, if I'm not mistaken. But I just want to give the example that I've got here. I've got a tree with 1422 nodes. Okay, so for example, let's ask the question. I want to know how many nodes are there at each level. How do I answer that? How many nodes are there at each level from the root?
you would need to compute each level and take the length of each level.
So you're saying that I would say tree level. No, I would. What would I do to
You
extract?
want like a table of tree levels at level n, and then you want to take the length of each of those.
Okay, so let's find out how I would do that. So I would say tree. Walk through how I would do it. So I want to get the tree level. Go ahead.
Do table
Of tree extract.
of tree level of tree, comma, list n. Just n, and then into from 0 to depth, tree depth of tree.
Okay, so let's, and then each of those, I want to say length of that tree level, right?
Mhm. Yep.
That's taking a very long time. Okay, cool. All right, well, I wanted to compute that before. Okay, so that, and how would I compute? Does that give me enough information? No, it doesn't give me enough information to know the number of leaves, or does it? It does. It's off by one.
It does not have enough.
No, it does. It does. Look, the tree size. Oh, the tree size is the number of nodes.
If you had done negative levels, then the number of leaves would be level -1. But you've done positive levels, so you can't tell how many leaves there are.
We just crashed. There is a bug. Tree level 0. Shoot. That's an unfortunate crash because I lost a lot of stuff here. Oh well. Right, the bug. See the bug?
Yep.
Okay, you've got a crash bug when there's 0 there. But that should have added up correctly, right? And tree level 0 should be the root node, correct?
Oh, you're the size of the tree, not the number of leaves.
Yes, that's correct.
Okay.
I was checking that the size of the
following,
tree
yep.
is equal to the sum of the number of elements on every tree level.
Mm-hmm.
Okay, so let's come back here. Let's say I want to know. It's very annoying. This just did that. It's very annoying. Just so you know. It'll take us like 10 minutes to recover that. Okay, well, we won't bother here. Okay, so question. Okay, so first question is, how do I get the top of the tree? And by the way, I assume you're fixing all this stuff about being able to visualize trees without getting, where these just nodes there, right?
Yes.
Is that, can I do that right now with
No.
something? Okay, the sooner that gets fixed, the better. I mean, do you have code for it now?
No, I have lots of documentation.
Okay, all right. Well, I mean, honestly, it's quite unusable. I mean, I have to convert these to graphs to use them in order to. Okay, but let's come back to this question about enhancing part specifications. And Jose has made the point that we should be thinking about enhancing extract specifications rather than part specifications. I wonder whether we can save. Here's a question. First meta question is, could we make an extract like, okay, so let's say, I mean, this might be crazy, but let's just say that we had a thing called parts in here that essentially turned this into an extract like specification. Is that completely bonkers?
You have suggested this a number of times. The problem is that we should not touch the one-dimensional nature of part. For example, you have suggested having something that extracts a diagonal with part. I think we should not do that.
Yeah.
What we should do is to have multiple and flexible symbolic position specs that are understood by the many functions that take position specs, not just extract. Also delete, replace part, map at.
Okay, but so what about, at least in the one-dimensional case, we can certainly have those work. I mean, okay, so what you're saying is that, the two-dimensional case is hard to make work for part because we're not being given sort of a complete object there, because we're doing this factoring of, this outer product of levels in part.
Exactly. So for part is absolutely fundamental that when you have a sequence of part specs, each one is at a different level. So if you have one part spec that crosses different levels, it will confuse.
Okay, so let me just understand. So let's imagine it's a select in a part spec. It is perfectly possible to do the select at that level, just like dataset does it.
Exactly, but it has to refer to the elements of that levels that are probably lists. It cannot go
absolutely
deeper.
Yes, yeah, I agree, but so does dataset, right?
Yes.
Okay, so but there's nothing wrong. So what would happen if we tried to support something like this in part?
I mean, as long as it is 1D, it might be doable, yes.
Okay, so let's understand the semantics. So in the case of dataset, the semantics there are, what is the semantics in dataset? What can you do? What exactly are the possible things there? Why is this so slow? What is happening here? Okay, can somebody please report this? Avery, I think that's for you. Again, and find out why it's doing this again. It's some kind of stupid startup of some search system, which should be done asynchronously, as I've said like 500 times.
Yep, I can do that.
Okay. All right, so now here, okay, those are all fine. Okay, what are all of these? Are these hacks, or is there a general representation of these?
So, I mean, this has a way of working, which is, a bit unnatural, but it has a way of working, a systematic way of working. So the operators are characterized by being, how is it called? Ascending and descending.
Right.
And what you have to do, if you have a data set with a list of these operations, each one in an argument of the query, then you need to know which ones are ascending and which ones are descending.
So what we mean by ascending and descending is they look down in the tree or they look up in the tree, basically.
Not really. So what happens here is that you start on the left. You start with the first one, and then you go towards the right, and those that are descending, you will evaluate those at that time. Then you go to the end and go back, and then you evaluate those that are ascending. So the question here is that when you have a list of these operators at different levels, in which order do you evaluate them? Because it's not commutative. Some of them are going to affect the levels, and they will introduce a new level, for example, group by. So it's very important to know in which order they will be evaluated. And this is the syntax.
All right, but so if we were going to untangle this into a function to apply outside of dataset, right, what would we do? So these functions,
so it
problem
would be
is
a query too. It would be a query as well, and it would have the same syntax.
Yeah, but okay, fine. But the issue is, one of the things that's happening is these functions are applying themselves to a particular level. Okay, so here's a question. Let's say I have an array. I have this array, right? What does it mean if this was in a data set and I was applying a function f? Let's see. So in data set, I could do, if I'm not mistaken, I could take the data set of this and I could apply identity, F identity. Am I right? Am I wrong? Oh, for goodness sake. Well, let's do normal of that. Okay, what happened here? Did that do what I expected it to do?
It's applying
Yes,
F
it did.
at the second level. Yeah.
Right. Okay, how do I do that? How do I do that with some function outside of dataset to apply F at the second level to achieve the same result as this
Map.
at level 2? I see
Mm,
what you're saying. You're saying map F onto this
Mhm.
at level 2.
I think in this case it will just work like this.
No, it doesn't work.
Well, map, like to this is the confusion between apply and construct. So we are mapping at level 1 so that we are applying F to the elements that are level 2.
Okay, so what is the analogous thing that I should use for this?
Just change the 2 to a 1.
Or could I change the map? No, I cannot change the map to an apply.
It would be like construct at level 2, something like that.
Is there a version of construct with level specs?
No. If there was a level spec version of it.
I'm very confused by that. Wait a minute. Construct just takes FAB.
Mm-hmm.
No, it just takes FABC like this. It's varargs. I'm very confused. What would it mean to say at level 2?
Well, what I'm saying is that construct of F, X, we could say that that's constructing at level 1, at the first level. If you had construct of list A, B, you could be constructed at the inner level, at level 2.
I see. Okay, I think that's, yeah, okay. We don't have that option anyway because it's a varargs function. But okay, so my question here is, as we think about generalizing.
So again, imagine that you have this array, and instead of saying identity F identity, you have FGH. The question is, in which order do you evaluate the F, the G, and the H?
Because it will change because when you do the F, G, and H. Okay, let's do that.
So this is assuming, I don't remember whether things by default are ascending or descending. I guess they are descending by default. And so you see how.
So it already changed by the time you inserted the F.
Mm-hmm.
That changed the level for the G's by increasing them by 1 because you stuck an F there.
Exactly.
Is that correct?
Well, and these could have done something already. Imagine that one of these G's was a group by. So that group by has already introduced a new level.
Right, but so the question is, does the thing, we could have labeled this. So what we could have done here is we could have given an association. 1 goes to F, 2 goes to G, 3 goes to H. And we could have said, apply those functions at those levels. I mean, here we could have done some very bizarre thing. We could say, level map or something,
mm-hmm.
of something like this, comma array. Okay.
Mm-hmm.
So
I think my point is that so far with part, we don't have these problems because the only thing it does is part extraction at each level, which is fully independent. Each level is fully independent from the others.
Yeah, right.
So if we do these extensions, we will have to worry about this ordering things, etc.
Well, you're saying if the thing basically modifies itself because part is a layered creature that goes level 1, level 2, level 3.
Mm-hmm.
Yeah. Okay, but let's come back here to what we were talking about. We've got this take after concept, which was the original thing. And I'm asking the question, why aren't we doing? I mean, clearly, if we had sort of more complicated specs, we would say things like take blah, 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 select prime Q, which would be equivalent to just saying select prime Q of the array. See what I'm saying?
Yes. I'm not sure I would put it in take, but
yeah, it's kind of silly in take. I'm sorry, I didn't mean it in take because it's really got it's producing a list of indices. Well, okay. So it clearly would be useful. Okay, having the ability to, I mean, is this useful to be able to say, that's the equivalent of the take after business, right? That's saying, find this as the position and then do arithmetic on that position.
mm-hmm.
Well, okay, I really do think it's worth exploring, enhancing our position specs, because I think, go ahead.
I was going to say, so the third subsection under here, there is a note about position index, which I don't really ever see used very much, but the
I don't either.
Is,
I forgot we even had it.
Yeah, so I don't necessarily think a second argument would be particularly useful there, but trying to think in terms of, we said, finding the max position within a array, or finding the maximum value within an array is a common operation, or the minimum value. There's a handful of operations where we need to effectively look at the entire array, and then we want to pull an element out, and I don't
find
know
its position and find its position.
Yeah. And so there's kind of, yeah, sorry, go ahead.
That's essentially what the last section is doing. So a problem we always have here is that finding the largest, for example, is potentially a list of positions.
Yeah.
Position. And so that complicates things a bit.
Well, okay. So, I mean, one thing we could imagine is something like, this is like saying, okay, so what is it? It's the equivalent of saying position of, well, it's kind of trivial. Why? Oh, I see. Position in list of f of list. That's basically what we're talking about, right? A function that basically just does that. Correct?
Yes, and potentially extract from list.
Why do we want that? I mean, cases would do. So, oh no, I see. Go ahead. Yeah.
In TakeLargest, we do want to extract the largest object, not just the position at which the largest object is. And so we invented this extended notation for TakeLargest to avoid having to do several traversals.
Yep, and that's the next section here.
Right, and this works well, but it's a not very standard notation.
Do we have this implemented?
Yeah.
Mm-hmm.
I've never used this.
Is this
in TakeLargest?
Yeah. And for example, in TakeLargest by, it's also able to extract the value before and after applying the function f.
Okay, so hold on. I've not used this. When did we insert this? When did we put these in?
Couple of years ago. This was something that Rob implemented. I think we use it also in Nearest.
Yeah, Nearest, I have used it. Sandra's saying he uses that notation all the time and it's terrific. Well, good, because I'm just behind the times.
I use it too. It's quite useful to get
like
all at the same time.
I like the functionality, if not the syntax. I mean, it's a little confusing to do list comma all, but I don't remember the original discussion about why it was done in that fashion versus an extra argument or something, but
I think TakeLargest or and TakeLargest by already have 3 arguments and you want to default the arguments. That's the reason.
right. Yeah. Okay.
Yeah, and we wanted a notation that can be extended to other similar functions, like in Nearest.
Okay. Yeah, without having to add an argument all over the place. Okay.
Okay. Well, we already had the one for Nearest for this.
Mm-hmm.
So, yeah, I mean, the bizarre thing here is that max itself applied to a list, what it would be doing is having an index. What we're asking for is an index property for max in some sense. If I'm not mistaken. You know, max by default is returning the element that is the maximum element, but there's also the index of the maximum element.
Right. So here in TakeLargest, it's using effectively max. Now the thing is that we have to specify how many elements you want, and you don't know how many copies of the max element there are. For example, imagine that you have a list with 7 largest elements.
Oh no, I know,
equal.
I understand.
Yeah.
I understand. Right. I mean, this is the problem that max returns. I mean, it's like commonest. Commonest has to return a list because there may be multiple maybe multimodal, so to speak. The list may have many modes. Wonder how the term mode got used for the commonest element in something. It's a very weird term. Okay.
Yeah. So this list, I think that's why we introduced the word take there, because we started with largest, but that seemed to suggest you would get only 1.
Yes. Right. No, I remember, and that was a good decision.
Indeed.
Okay, so let's come back again here. What are our directions here? One is enhancing part specifications to be able to look inside at the data. Okay, so that's a question. Do we want to do something like that? The second is and I mean, for example, I would consider up to a huge success. I mean, I use it all the time. We've inserted it into functions like partition and, you know, all this kind of stuff and take and so on. Do you agree it's a huge success?
So
I do.
I agree it's a huge success, but I would say, I mean, the thing about these other computations is that up to, like, so I think if we have all quote unquote ascending operators or all quote unquote descending operators, then it's kind of okay. But once we have both of them, then we have all the problems that dataset/query have with having these, you know.
No, I agree with that. I agree
Thing.
with that. So what is a descending operator is one, let's see, rather an ascending operator. Those are the more obscure cases. The ascending operator.
So usually the descending ones are like are more map-like, and the ascending ones are more reduce-like. They're like aggregation functions, right? So you might do something like you might map on the way, you might map on the way down, or in this case, select or something like that. And then the point is that when you apply total, you want to apply total to the filtered processed data, not to the data, right? And you don't want to apply select after you've applied total.
It's essentially a map reduce combination. So one feature of the map combination is that it does not change the level structure. Is that true? It could change the level structure. You could introduce another level of list, couldn't you, by the map operation? Or am I confused? Or does the map operation merely...
I think you can't remove layers of list with map. So it's not an aggregation function.
But you can add...
I guess you can actually. That's not true. You can, because you can, if you have a deep list and you map over it, you can get rid of some of the deeper levels.
So we have map all that can map at different levels. I think it's first going to insert the functions and then let them evaluate, and they will do whatever they do.
Yes, that's what map does. I mean, map is just purely sprinkles the function, and then the evaluator is called, and it does what it does.
Yes.
The difference here, go ahead.
Sorry, what I mean is that with map, we will insert f once at one particular level. When we map at different levels, we have the question of in which order these evaluations are going to happen.
Yeah, exactly. So I mean, my point is, if we say, inactivate, well, it doesn't really matter if we just are saying, how do I get an expression with some depth to it?
Groupings or array.
What's that? Yeah, okay.
Some groupings or array. Mm-hmm.
Actually, groupings would be nice. No, sure. Or do I just want... Okay, so now here, if I say map capital X onto %9, map all capital X onto %9. Okay, now the question is, what's happened here is all the X's have been inserted. And conceptually, then the evaluator is called and all the X's evaluate.
Mm-hmm.
Now, in what sense does dataset not do this? In other words, how would I get the expression that is the equivalent expression to a dataset thing with a bunch of counts and selects and so on?
So imagine that instead of having X, we had a list of functions that are mapped at respective levels.
Yes.
So then at each level, we would insert a different X, and then they would be evaluated depending on whether they are ascending or descending. We would evaluate first the descending operators and then the ascending operator.
I don't understand, because if we just look at the symbolic expression generated after sprinkling, so to speak.
Yep. But dataset doesn't sprinkle first and then evaluate.
I know, but could it conceptually do so? What would it look like? What would the expression look like that is the post-sprinkling pre-evaluation expression?
I think it would be less useful, because the thing with dataset is that you may have a group by, for example, and then you rely on that group by is going to be evaluated before something else does something to the result.
I understand that, but I'm asking, if you looked at the expression post-sprinkling, what would you see? And you're claiming that there is no expression that can be generated post-sprinkling that could be just evaluated from the top that would give the same results as dataset.
Yes, I believe so. That in dataset, it's important that we insert and evaluate, and insert and evaluate.
I'd like to
appropriate.
understand that. Could we look at that a little bit more carefully? And I'd like to understand that, because in other words, you're saying that there is no map-like thing that will do the insertion of operations that data set is doing.
Well, remember that with dataset, we have this compilation that can express a given query as a sequence of standard Wolfram language functions that would do the same.
I know, I understand that, but I'm asking if we did it as a static sprinkled expression, is there a version of this? In other words,
I see.
if we looked at MapReduce type stuff and we did it by sprinkling, I think we would just see reduce of map f comma blah all over the place. That's what the map and reduce would look like. They could be done in this way, I think. I think they just nest an expression, don't they?
When you say map reduce, are you referring to array reduce?
Maybe I am. I mean,
I thought array reduce was a little bit different.
Because reduce is a
that's just
general
reduce.
kind of operation that, I mean, reduce just means you take an array with some dimension and you use some reduction operator, like total, for example, on it.
Mm-hmm.
You're mapping from an array type to a scalar type, let's say.
Yes, but here we are dealing with operations that are the opposite of reducing. It's, for example, group by will produce a new level that wasn't there.
Right. Group by is sort of an anti-aggregator, but most of the functions that, I mean, I would say there are like a couple of those operators like group by, gather by, but most of them are more aggregation.
Okay, but I think what must be happening then is that once a group by is in there, that the thing that is above it is not something which is a predefinable. In other words, it somehow gets inside the result of group by in a way that isn't standard function composition. That's what has to be going on.
Right. Yeah, it's important that group by gets evaluated at the right time for the next function to do the right thing.
I know, but I think that there is a way of writing it. Okay, I'm claiming there is a way of writing it like this, except that the thing that comes outside of the group by will not look like f of group by of list. It will instead look as, you know, some kind of weird apply of f comma group by of list. That's what I claim.
Mm-hmm.
Okay, and the question is, what is weird applied? It has to be that there's something like this that it's doing. Right, that in other words, okay, in dataset, when it is doing an ascending operator, okay, I am so confused here. See, I claim, without enough justification, that there is an up to like thing going on for levels. That the reason we run into trouble here is that there's some kind of thing which is some corner case that is like up to, but it's about, you know, how we map things or something like that. Because there's got to be a way, again, there's got to be a way to write this out. There's got to be a way to write out query
I'm going to put something in the chat.
special operators. That's just horrifying.
Stephen, can you evaluate what I placed in the chat?
Yeah.
So for example, if you have this query with a group by in the middle, that gets converted into that. You see the various compositions and mappings, etc. So for example, the fact that you have a group by made H to be mapped so that it's mapped at the right level that has been produced by the group by, etc.
Okay, I think we need to understand this more. So you're saying
so notice how things are first F, then H, then G, even though we wrote F, G, H.
wait a minute, the /@ operator. So if I say f/, I never use these and I really should be using them. That thing there applied to X.
I mean, the thing is that the data set does not run, it takes apart the compositions. It doesn't run them in order.
If I give it composition at all.
Yeah, if you give it a composition, it will not necessarily run it in the, it symbolically takes apart the composition and may run it in some weird order. It may even, it'll run it'll run, there's sort of like, it'll run the things in the composition in the order you've put them, except it might jump down to a lower level, then jump back up to finish your composition, if you know what I mean. So you don't know that the whole composition is going to be run at once.
I think we need to understand how dataset compilation works better.
So if you write, for example, FGH, you see that things are kept in order.
Well, FGH in what? And just FGH in the query?
Yes, in the query, or it will be data set of FGH. So
what's that map doing there? So what the heck is this? So that thing applied to X.
You need something deeper because
exactly.
FGH it needs to be like level 3 at least.
Yep.
This is equivalent to running map, and then the mapping function calls map, and then the mapping function calls map. So it's applying F at level 1, G at level 2, H at level 3. Or F at level 0, but yeah.
This is applying the deepest thing. So it's the first thing. So it's applying this first. Oh my gosh, this is confusing. So it's using the, okay, just so I understand, map F applied to ABC does that. I am fairly confused here. I mean, in other words, this thing here, I feel like we need some version. I mean, there's a bunch of heuristics built into query.
Yes, the key point here is to remember which type of operator one given operator is.
We had always meant to go back when we originally designed these ascending and descending things. We had originally always meant to go back and kind of try to understand with more clarity what all this stuff meant. Sandra is commenting the syntax with the arrow will be very useful in select because it could return index and element. What would that be analogous to? TakeLargest by. I see. So you're saying we could be saying, although could be saying select in the list ABC arrow index. That's interesting. Let's take an example. I don't know. Let's not use range because that's going to do something silly. Okay, basically here, hash greater than 0 or something. Which is not something we can achieve with position right now. I mean, with position, what we would have to do is we'd have to say position of, I don't know, and then we would say x blank slash semi x greater than 5.
You don't need the ampersand.
Oh, yeah, right. Okay, so that's how we would do that. But the alternative would be this thing above it with a select returning an index rather than an element. Is that doable? I mean, seems like it will be doable. Same as TakeLargest by.
Mm-hmm.
I wonder what, yeah, go ahead.
Sorry. I think the important thing here is to avoid multiple traversals, because if you want both the objects and the indices, you can get to them both at the same time.
Sure, although it's also syntactically nice to be able to say, I don't know how syntactically nice this is, because to get those indices, it's a rarer case to want the indices than to want the elements. Okay, Nick is saying you can always write function composition. Oh, the data set, you could always write the query, you can always write as a function composition. And Nick is pointing us to select positions, which is doing exactly this thing. Cool. Yeah, that's doing exactly this. Okay, look, my conclusion is that there needs to be a better study of the calculus of operators applied to nested arrays. Right, this has been okay, there are 2 points here. To what extent can part specifications, have things that refer to content? That's point 1. And how do we think about, yeah, I mean, let's try to study this query thing a bit more. Maybe we can ask Tally to make a special guest appearance. Anybody want to have further comments on this?
Perhaps this is another thing for the data container discussion, because that thing is going to be closer to dataset, and it could have capabilities that normal arrays or part don't have.
I agree, but I think we need to understand better. Look, we've got to understand ascending and descending operators better. It's been put off for a decade. We need to understand it now. And with our success of threading, which I think is going to looks very nice, that's a great example of innovation in arrayness. I think there's more innovation in arrays. I mean, look at our successes in arrays. We've got nothing, we've got up to, we've got splice, we've got threading. These are all array innovations. I reckon there are more array innovations to be had. And something we need to look for, because I think what we're saying is, look, the main point is function composition. Okay, so one thing we could do is, f of g of h of array. Okay, but what we're saying is there are more sophisticated ways. Okay, so a naive thing, as we already talked about, is something like a one naive thing we could do, which I think is like data set, is say level map. Level 1 is this, level 2 is this, level 3 is this. Because that's map all, but with different levels, with different functions being mapped on different levels. Am I right?
Yes, and this could allow controlling the order, because you could start by saying 2 to G and 1 to F.
Yes, that's a good point. Right, and so that would have an elided syntax potentially of FGH, which means those successive levels. And that would then be, but then this is, okay, what would this do? So level map here, what does this return? What is the sprinkled version of level map? Okay, so look, level map. Let me just understand what the ascending and descending versions of this would be. So 1 arrow F, 2 arrow G. Okay, of, let's say, A, B, C, D. Okay, so what would this be? This would be at level 1. I mean, what I'm assuming this looks like is it like this? F of G of AB, comma, G of CD. Is that what that does?
Well, it depends how we interpret level 1, whether it's, for example, map interprets 1 as
yeah, all right, okay. So let's, all right, let me just change this to 0 goes to F, 1 goes to G.
Okay, so yes, then that would be like that. Now, this is assuming that they are both descending, so we evaluate them in this. Okay,
okay, wait a minute. Now, so you're claiming this is both descending. So then what does it look like if one of them is ascending?
So I think the way to understand this is to convert into a sequence of maps, of nested maps, and then we have to worry about the order in which we place them. So in a sense, once you have sprinkled, you have already decided an order, which will be the order in which the evaluator will handle this. But you can express the level map as a map of something, of a map of something.
Okay, so wait a minute. So another thing to do would be, changing the evaluation order. Okay, so this is my favorite kind of issue of the day, is reordered evaluate. So normally, if we did f of g of x, normally we know how that evaluates. But reordered evaluate, where it says, for example, so normally the normal evaluation order is do level 2, then 1, then 0. So we could say, for example, do level 1, then level 0, then level 2. But maybe we couldn't, because some of those levels might have disappeared by the time we get to them.
Mm-hmm.
That's the difficulty, is that what do we do? How do we specify what comes next if we can't use the predefined coordinates, so to speak? There are predefined coordinates. Haven't we seen this before with covariant? To what extent is this like some kind of covariant derivative-ish thing, where the thing kind of moved before you thought you had a coordinate, but the thing moved from under you, and what does your coordinate refer to now?
I don't see a connection with covariant and contravariant.
No, it doesn't. No, I don't mean covariant and contravariant. I mean the notion of we're talking about where does the derivative in a covariant derivative, there is a where the thing got applied to before the fluid moved, so to speak. There was an original coordinate, and then there's a coordinate that's sort of fixed to the fluid, if that makes sense. And so similarly here, you can imagine that there's a coordinate that's fixed to G, but the level of G moves around because of ambient stuff going on to it.
Mhm.
So that's what I mean by that. That somehow.
So we have several functions that have an argument to control at which level you are doing things. Like for example, I think it's the fifth argument of inner.
Yes.
So it's this sort of at which level do you want to apply or multiply?
Right,
something?
but the point is that inner it is easy to compute, although the levels that it creates are not what it started with. They're a simple summation of what it started with, so to speak.
Yes, but there are several possibilities at which you can control, at which you can do the operation, and you can control the orders of the first of the arrays, not of the second.
Yes, but I mean, what we're saying here, okay, the fundamental thing is our usual evaluation order is what it is. We are trying to, for array purposes, we are trying to change our usual evaluation order. But again, I think the problem is labeling where we want to do something. We have our original coordinates for labeling it. And what dataset is doing is it's using some original coordinate system, and then it's ascending, descending things. It's like what should flow with, that's maybe a weird way to put it. But yeah, I mean, look, I think we need, I mean, this level map thing. Let's think about this, because that hopefully what that is doing, or it could also be level apply, I'm not sure. The point about level map is that it will never change. It might add a level to the thing, but it will never be the case that an outer level will no longer be able to see things of the right structure underneath it. Right? Because it will have applied that function f to a series of islands, so to speak, on the level below. You can still always look at those islands. The islands might have been encased in f's, and the f's might have evaluated all kinds of other things, but there'll still be a bunch of distinct islands there that the higher level function can apply itself to. That makes sense.
Mm-hmm.
But then if there's an aggregation function like a total, then the islands could all be gone. And if you tried then to do a function inside the result of total, you're toast.
Well, somehow dataset try to autocorrect when it sees, because it knows the behavior of various functions, it will say, oh, you added total. So the next function to apply will do it actually at a level less. That's why it has all the time these maps of maps to correct the level.
Yes, I get it. This is probably a branch of our arrays discussion. There's another, this is operations on arrays. We've now got three branches. We've got threaded. What are we calling it? Is it threading or threaded?
Threaded.
Threaded, right. Okay, so we've got threaded, which seems like it's coming to a conclusion and a great conclusion. We've got the data container stuff and the backing of that. And this is the third branch, which is the, yeah, I mean, this is a good thing to be thinking about. This is how do we apply functions at multiple levels? What is the convenient way to apply many functions at multiple levels? And we have an existence proof in dataset that there's a reasonable heuristic way to do that. And for each one of these things, I mean, I don't know whether you can also think about this usefully in terms of type calculus and so on, what's going on inside here, of what is mapping, lists to lists, lists to scalars, etc.
Dataset does a bit of that because it has a system to predict the type of a result given the type of the input and a query.
Right. Okay, well, this is very interesting stuff. Okay. It sounds like actually we've got another branch here, which is it another branch? The thing of using select in a part number, in a part specification. I think that's yet a separate branch of this whole discussion. Do you agree?
Yes, though, as I said, I would like to extend that to symbolic position specs, which is what I think would be really powerful.
Well, I agree. I think that's what we're talking about, is symbolic position specs.
Yeah, well, if they are in part, it's symbolic part specs, of which we only have.
I see. Right. You're saying we might have symbolic part specs, but they will be a junior thing relative to symbolic position specs suitable for extract and so on.
Exactly, and that they can cut across levels and take diagonals and things like that.
Right. Okay. Well, okay, this got more complicated, but we've got interesting things to discuss, and we can do some experiments, perhaps Nick and others, on things like level map, whatever level map should be.
Mm-hmm.
And also, sorry, the other thing is select. Yet a different branch is the possibility of adding, arrow results for functions like select. Right? Is that, where would we otherwise put that? Is that equivalent to one of these other things we're talking about? I'm not sure. Okay, so should we just make a quick list of these things? We've got we've got symbolic position specs, of which the example is extract array, comma, select, blah, blah, blah. Okay, we've got properties for list filtering functions, of which the characteristic example is select, this one here. Then we've got multi-level map, basically. Multi-level function application to arrays. It's almost actually a multi-level, it's almost multi-level map or something. I don't know, that's not quite the right name, but okay, what was the other thing we were talking about? Is there anything else we were talking about here? Guys?
We already covered the select with the rule, which was the other one.
No, unless you want to have some sort of connection with traversal order.
Yes. Well, and the generalizing to multi-level evaluate or something, or level ordered evaluate. I don't know. All right. Anything else?
No.
All right. Thanks all for now. See you all.